for the kinetic energy equation, by what factor will an object's kinetic energy change? So the variable in question is k. Now the equation's already solved for k, so we don't have to do any work for step one. Then step two is taking that equation and we're going to turn it into, it's no longer equal. We're going to write in everything that stays the same, and then we're going to write factors of change. Now 1/2 is a coefficient, so it gets a 1. In m remains constant, so it gets a 1. And v triples, so we're going to write that in as 3. And that is a squared term, so it gets that square. And so the factor of change is actually 1 times 1 times 3 squared, which is 9. All right, so our factor of change is 9. So the kinetic energy new is equal to 9 times the old kinetic energy. All right, let's take a look at the second. By what factor of change will, by what factor will the gravitational potential energy change? Okay, so once again, we don't, step one is a value or solve that equation for the variable in question, and it's already solved for it, so we just have mgh. Okay, by what factor will UG change? The mass doubles. Okay, so the mass is 2 times what it was, and the height is tripled, and G is a constant. So G gets a 1, and the height is tripled. All right, so the factor of change, again, these are not equal, I apologize, is going to be 6. Okay, so UG new, the gravitational potential energy is going to be 6 times the old gravitational potential energy. All right, this third equation will be unfamiliar to you, no problem. It says, what factor will the period of the pendulum t change if the length quadruples and the field strength doubles? Okay, so the variable in question is t. So we're going to use this. Now, there 2 is a constant, pi is a constant, L quadruples, and G doubles. All right, so the factor of change is going to be 4 over 2, which is 2, square root of 2. All right, so the new period of the pendulum is going to be equal to the square root of the old times the old period of the pendulum. All right, let's look at number 4. So we're looking at the acceleration, and once again, it's already solved for the variable in question. So we'll just use that. It says the change in velocity is doubled, so that's 2 times, and the time is halved. Times in the denominator, so it's going to get a 1/2. All right, so everything's changing in this case. Now remember I said that a fraction in the denominator is the reciprocal in the numerator. All right, so it's going to be 2 times 2, which is 4. So the new acceleration is going to be 4 times the old. And then finally, here's the work equation. By what factor will the work change? So again, the variable in question is work, so we're just going to look at what it's equal to. Force triples, the distance doubles, and the angle remains constant. Okay, so cosine theta doesn't change, so it's a 1. So the factor of change is going to be 6. So the new work is going to be equal to 6 times the old. All right, good luck. And if you have any questions, you can always post a comment in the assignment and we'll get back to you. All right, thanks.